Number 11, sphere. A sphere with a radius of 15 inches is shown on a computer screen. An animator increases the radius at a rate of 6 inches per minute. Write an equation that would describe volume as a function of time. What would the volume of the sphere be when t equals 3.5? And then there's the equation for volume of a sphere. Okay, let's think about what's going on here. We have a sphere, which I don't have 3D objects here, but I can draw a circle here. And remember, a sphere is just a 3D version of this. So you'd have the same thing, just coming out longwise as well. So you have something like, I think the way they would usually represent this is have kind of a dotted line going around this way, and this would also go around this way as well. And so we have this sphere. Now it has a radius of 15 inches, so let's think about a radius for a second. Radius is half the length of a circle, which means from here to any side is 15 inches. That's 15 there. Now the animator is increasing the radius of a rate of 6 inches per minute. So I'm going to say that minute is t, okay? T is going to be minutes. That's what we're going to assume. This radius right now is 15, but the radius per time is going to change. So it starts at 15 inches, but every minute it adds 6 inches. So that'd be 6t like that. That's radius. Now write an equation that would describe volume as a function of time. So here's volume as this equation. So now volume, here's how it would change. I'll say volume changing on time would equal 4/3 pi, and then we'd have r cubed. But we know r is the equation, let me write it this way, r of t cubed. We have RT given there. So I'm actually going to substitute in and say that the volume of T will equal 4/3 pi times, instead of R, I'm going to replace that with 15 plus 6t cubed. And so this is what's called a composite function. It's a function inside of another function, and it's given there. Now this could be our equation here, and granted we could work this out if we wanted to and multiply everything. I don't really feel like going through all that, so I'm just going to leave it in this form right here. But that would be one answer. The second thing it asks is, what is the volume of the sphere when t equals 3.5? Well, if we want to know the radius, we plug it in there, but we don't. We want to find the volume. So I'm going to come back over here and say that the volume at time 3.5 will equal 4/3 pi times 15 plus 6 times 3.5. And this is all cubed. So we'll go to our calculator, and I'll show you the different ways we can type this in. So one from the start is we could have written the radius to begin with as a function. But I'm going to do this final, just type this in like this and see what we get. Oh, I'm sorry. Control doc. I'm going to do this as a value here. So I would say the volume would be 4/3. So 4/3 times pi. Pi button's down the bottom left. Times, parentheses, 15 plus 6. And instead of t, we replace that with 3.5. Now I close that parenthesis, and I'm going to cube this. I get this volume here, which, let's see if it says what to round to. It does not, so I'll round to the nearest tenth here. Nearest tenth, 10 has 1 0, so it would be 1 decimal place. It would be 195,000. V of 3.5 equals 195,432, I believe it was. Yep. 0.2, and this is in inches. Inches cubed. This would be my second answer here. Now, if you wanted the calculator to give that to you from the graph, here's what I was going to show you. So you come back over here, and what you could do is do the radius. So the radius is the equation 15 plus 6, and I have to use x, I accidentally hit T. There it is. Okay, and then our second equation is the volume equation, which was 4/3 pi r squared. So there's the pi, but the r is actually the equation here, F1. Now, what do I do that F1? I need to cube this. Let's go out here. So I would cube it like that. And so this is our volume function. And now if you want, you go Control T, and we can get 3 seconds. You could change the table to count by halves. When you go here where I want it to step, the step is how it changes. I want it to change by halves. And so now I could get that when time is 3.5, I can get this number right there that we had earlier. The other way you could have done it is once you have these typed in, go back over your calculator screen and say that F2 of 3.5 like this, and press enter, and it'll give you your answer. As you can see, either way, it's the same thing. This is, again, a composite function.